Click the bell icon to get latest videos from Ekeeda.
Hello friends, I welcome you all to this video. We are with the chapter where we are having the learnings of image restoration. We started this chapter with a model of image degradation where we have seen a degradation function, and after that the various noise models have also been reported as like the Gaussian noise, the salt and pepper noise, the Erlang that is called as the gamma noise, and so on. The various noise parameters we have reported, these are not at all desired into the signal where we have the image in this particular subject. So now we have the different types of the filtering so that the image can be restored. As in the previous video we have gone through the learning of the mean filtering, let us have another type of the filtering so that make image restoration possible, that it is order statistic filters. So let us see the details. So here we start with our topic order statistic filters, which are basically working into the spatial domain. In the previous cases of image enhancement, we had two different chapters: image enhancement into the spatial domain, image enhancement while working into the frequency domain with the help of the Fourier forward and inverse transformation. So it is not the case with the order statistic filters. We are completely working into the spatial domain itself. So here the response of the order statistic filter is based on ordering, that is kind of ranking, hence the name order statistic filters. The pixels that are contained in the image area are encompassed by the filter function. The response of the filter that we calculate at any point is actually determined because of the ranking result here. Here we have a suitable unipolar and a bipolar noise that is called as the salt and pepper noise to be completely removed with the help of the order statistic filters. The very popular, the median type of the filter we shall be discussing along with the other types also. So here the various types we can list under the title order statistic filters. The very first will be the median type of the filter. Also we have the maximum or a minimum type of the filters. In the median filters we can take the case of 50% of selection value, whereas in the maximum the 100% the selection value. In the case of minimum filters, the 0th% of the selection we can do. Also we can also have the midpoint type of the filter. Next to that we can conclude with the help of the alpha trimmed mean type of the filters there. So we start with the first type, median filter. Median filter is the very popular and the best known among the family of order statistic filters. As the name implies for this particular filter, it replaces the value of the pixel by the median of the gray levels of the neighborhood of the pixel. So as we know that for the filter function possesses a neighborhood with respect to the local region. Most of the times for mean type of filtering, we either take the dimensions 3 by 3 or 5 by 5, 7 by 7, 9 by 9 like this, so that we can have the origin centered into the mask here. Now here such a neighborhood will be responsible to find out the median value, hence the median filter will be working there. So the median filter we can define with the help of the mathematical equation represented as f cap of x comma y. We need to make compute based on the median where we have s comma t, the variables belonging to the local neighborhood represented capital S suffix xy here, operated over the image represented small g of s comma t here. The original values of a pixel, it is included in the neighborhood and it is a part of the computation while we have the median calculated here. So now the median filters are popular because of the reason that the certain types of the random noise, they provide excellent noise reduction capabilities with the considerable less blurring effect, and the linear type of the smoothing filters of the similar size are reported there. The median filters are the particularly effective in the presence of both the bipolar and the unipolar type of impulse noises, that is nothing but the salt and pepper noise. So here we take the example here. So in this example, the image segment is shown to us with the 6 rows and the 6 columns. The first row values you can read out: 164, 156, 145, 96, 168, 188. The second row, that is 146, 135, 90, 185, 200, 198. So likewise we have the 6 rows and 6 columns in all. From this we have shown selected values in bold case. Those values are of the dimensions 3 by 3. We have 137, 83, 189, 94 in the second row, 255, 215, and in the next row we have 179, 221, and at last 200. See here, this selected dimension is centered at the value selected 255. When we take the case of 8-bit image, so for the 8-bit case we have the lowest possible value of the intensity represented by the number 0, whereas the maximum possible intensity value is represented with 255. So this 255 is the maximum value. So unipolar, bipolar, the cases that we represented here, so this is the one pole at the maximum value. So this is to be replaced. This is the noise. So this noise is to be calculated considering the surrounding values. The surrounding values are 137, 83, 189, 94, 215, 179, 221, and the 200, along with the value reported at this place, that is 255. So when we arrange all these 9 values into the ascending order, we have a sequence starting with the lowest 83, then 94, we have 137, 179, then it comes 189, then 200, 215, then we have 221, and at last we end by 255. So when we take a median of this ascending sequence, this particular sequence gives us the mid value at 189. So the concept is very simple, that to replace the value 255, which is the noise value, by the median value 189. So upon doing this, the resultant image segment will be like this. So whatever it has been highlighted with the bold case here, so here 255 is replaced by 189. So this is called as median filtering. So this example we have taken for the maximum possible value. On the other hand, we take the case that the pixel has 0 value. So in the 8-bit environment, 0 value, the lowest possible image intensity is represented here. So this is a case of another kind of polar noise, and it is to be replaced by the median filtering here. The neighborhood here, again we have 137, 83, 189, 94, 215, 179, 221, and lastly the 200 here. So here arranging the order of the image pixel intensities into the ascending sequence here. So ascending sequence starts here with 0 as the lowest value for the center here. So after 0 we have 83, 94, 137, 179, 189, 200, next to that 215 and 221. So taking a median, we come to the value 179. So thus in the place of 0 we can substitute the value 179. So see here on the right hand side we have the same image segment where the salt and pepper type of the noise for the 0 value represented here is replaced. So this is the filtered image segment. Now here we have a center value of 3 by 3 pixel dimension represented into the original image, replacing by the median value here. The median filter technique is applied for each of the non-overlapping block of the 3 by 3 pixels, and from the top left corner to the top right corner and from top to bottom we can go in application of this median filtering here. Now there are three different kind of the situations while we can apply such a median with respect to the neighborhood. In the first case, you can see here that the filter mask is completely inside the image segment. The origin is also of course inside the image segment here. The computational block here overlaps only the pixels that are a part of the original image segment here. In the second case, it becomes quite difficult to apply the median type of the filtering here. In the previous case, all is okay. In the second case, we have the computational block that overlaps the pixels outside the original image. See here, the upper row is outside the image span here, but the center of the pixel, the value that is to be replaced by finding the median, is a part of the image here. So this question is to be addressed here. In the another case, we have a situation that we have the neighborhood selected such that the center and few of the elements are outside the image span. The computational block here overlaps pixels at the edges only. The center pixel is completely outside the image span here. So here we have the exact example working with the images here. So here we have 4 parts represented. In the part A here, we have the representation of the image that is affected by the paper and salt type of the noise with the density value of 0.2 here. When we apply the median filtering, taking the 3 by 3 dimension for the filter function, the result of the first part we visualize here. So here we visualize a complete clear image which is not totally affected by the salt and paper type of the noise. Next to that, here we have the intermediate result into the part B of or the second image that we have obtained by application of the median filtering. Further again we continue median filtering here, so that generates this part C of the image. Next to that, we again can continue with the median filtering. So as we see here, the dark and the white spots into the median, into the image 2, 3 have been reduced into the image 4 here. So this is the application of the median filter where the original image is affected by the salt and paper type of the noise here. So here the repeated passes remove the noise better, but also blurs the image up to certain extent here. So after completion of the median filtering, we shall be discussing about the max and mean type of the filters here. Although the median filter is popular, the order statistic filter of this particular type is mostly used in the cases of image processing, but not by the means the only one here. We have alternate options as well. The median filters we discussed represents the 50th percentile of the ranked set of the numbers here. But from the basics of the statistics, we can also rank the selected values to many other possibilities here. So for example, using the 100th percentile result into the so-called max filter, we can perform here. So it can be given mathematically representation of the filtered image f cap of x comma y computed by having the max operation with the variables s comma t belonging to the local neighborhood capital S suffix x y here. So this is operated over the image that has been degraded, that is represented g of s comma t. So this filter is useful in the cases of finding the brightest point into the image segment here. Also, the better paper noise has a very low values, so it is reduced by this type of the filter, and as a result of the maximum selection of the sub image area, that is the neighborhood capital S suffix xy here. Now if we select for the 0th percentile of the neighborhood or the local region, we can get the form of the filter to be the mean filter here. So mathematically we represent this filter function as f cap of x comma y computed as mean operation with the variables s comma t both belonging to the local neighborhood capital S suffix xy operated over the degraded or the noisy image g of s comma t. So this filter is useful for finding the darkest point into the image. Also, it reduces the salt type of the noise as a result of minimum operation here. Now we can discuss about some of the noise reduction examples. So here we have the two images and the next two for this example. So the first image is affected with the paper type of the noise with the density 0.2 that you can observe in the image scenario. Whereas the second figure is the representation of the image that is affected by the salt type of the noise here with the density 0.2 here. So on the left hand side we have the first image with the paper noise, on the right hand side the second image with the salt type of the noise with the equal type of the densities 0.2 here. Now the first image we filter with the max filter of the type 3x3 dimensions here. So this is the resultant image we obtain in the part C here, or the part third image here. On the other hand, when we filter the salt noise affected image with the density 0.2 with the mean filter having the filter mask dimension 3x3, this is the resultant image here. So both the images are clear and with the reduction of noise on comparison to their original ones. Next to these max and mean filters, we have the midpoint filter. So the midpoint filter simply makes the computation the midpoint between the maximum and the minimum values in the area encompassed by the filter here. So here we have the representation in the mathematical form for the filtered image f cap of x comma y obtained by taking half, that means the midpoint, operated over the max filter operation into the first term, that is max with the variable st belonging to the local neighborhood capital S suffix xy operated over the degraded image, the noisy image represented g of s comma t. So this is the first term, and in the second term we have the mean operation of the filter for the variables s comma t belonging to the local neighborhood capital S suffix xy here operated over the image represented as g of s comma t here. So here this filter combines the order statistic and the averaging filters. So order statistic filters are inside the square bracket, and outside the square bracket, as we are making half, so it is averaging, it is mean type of the filtering. So it is combination of the two here. So this filter works for randomly distributed noise like the Gaussian or the uniform type of the noise here. Next to that we have the last type of the filter here, that is called as alpha trimmed mean filter. So if we delete the d by 2 lowest value and the d by 2 highest value of the gray levels for the image represented g of s comma t into its corresponding neighborhood, we obtain the alpha trimmed mean type of the filtering here. So let us represent g suffix r of s comma t representing the remaining, that is mn minus d pixels here. A filter that has been formed by averaging these of the remaining pixels is called as the alpha trimmed mean type of the filter here. So mathematically we represent the filter function and finally the filtered image small f cap of x comma y, the spatial domain parameters here, computed by 1 upon mn minus d along with a summation operation with the variables s comma t belonging to the neighborhood capital S suffix xy computed over the image represented here g suffix r in the parenthesis s comma t, the variables here. So this is the middle represented mn minus d pixels here. So the value of the d that can range from 0 to mn minus 1 here. So when d is equal to 0, the alpha trimmed filters can reduce the arithmetic mean type of the filtering. If we choose d is equal to mn minus 1 divided by 2, the filter then become the median type of the filter. For the other values of d here, the alpha trimmed filter is useful in the situations of involving the multiple types of the noise, such as the cases of the combination of salt and pepper and also the Gaussian noise as well. So let us have a look onto the noise reduction example using the filters here. We have the 6 images in total. The first one image is the image affected by the uniform type of the noise with the values m is equal to 0 and s square is equal to 800 here. Whereas the image further corrupted by the pepper and salt type of the noise is represented on its right hand side, the second image. The third image is the image obtained by filtering the image with the arithmetic mean type of the filter. The filter dimensions mask we have taken 5 by 5. The filtering by 5 by 5 for the geometric mean type of the filtering is obtained into the fourth image here. The performances you can notice after comparison here. The filtering by 5 by 5 type of the median filter we show into the fifth image, and finally the filtering of the image by 5 by 5, the alpha trimmed mean type of the filters with the value of small d is equal to 5 is represented into the last image. So I hope the order statistic filters are very clear to you people, so that we can perform the image restoration, one of the fundamental step of digital image processing. By the next lecture, we carry forward the image restoration processes, and this time we shall be with the adaptive type of the filters for the same objective here. So for more information and more knowledge of the subject digital image processing, you can subscribe to Ekeeda channel. Thank you.